Obviously. Factoring polynomials. Now, think back. When we factor, we take something and we break it into two pieces being multiplied, right?
Yes, ma'am.
If you think about it, this is a form of division, right?
Yeah.
Because 6 divided by 2 gives me 3, so the two factors multiplied together. So what we're going to do before we actually start division of polynomials is we're going to talk about some factoring of polynomials, all right? And we've already done some of these special patterns, and I'll just review with you real quick. These are all on the sheet. I can't remember if I'd given you this sheet before or not. No, yes, maybe. Just as a review, and we've already done this one, the difference of two squares. If you want to, it's all on the page I gave you, guys. Difference of two squares we talked about is exactly what it sounds like. It's two perfect squares separated by what kind of sign?
Square root.
It's difference, subtraction. When it looks like that, how does it factor?
49, 7,
Square root, somebody said square root, x plus 7, x minus 7. Okay?
Because when it's a minus sign, it's going to be both mixed numbers.
Okay? So that's assumed that you remember and that you know. Okay? Guys, I see lots of laptops out. We don't need them right now.
She's not like the first way you put them up.
McGee, I'm your younger.
We also talked about perfect square trinomials or PSTs. Remember, these are the ones that have to square dance. The ends have to be perfect squares, and I'm running through these fast because we've already done them. The square roots of the ends multiplied and doubled have to give you what's in the middle. It could be the second sign has to be plus, the first one can be a plus or a minus. How does this one factor? One what? Not just one, but 1x. You take the first sign, and you said 6, and this is just squared. Sorry. I said take the first sign and didn't write it. Is all this coming back to you? Remember?
I don't remember doing this. Maybe they remember if you do the box.
You can do the box, but they get really big.
Oh, God. Do the box. Now you remember? Yeah, the box.
Well, but here's the problem. We're getting ready to do something where you're going to have to be able to recognize. Remember I told you, you do the box for a little while, but you're going to have to be able to at least recognize a perfect square trinomial. And this is where we said the ends are square, square. Then if you multiply and double, you should get what's in the middle.
What?
What? What?
Oh my God.
What?
I don't think she was serious. She was. I don't know what she
X plus 6 squared is the same thing as x plus 6, x plus 6. So the original equation was x squared plus 12x plus 36. If you put that in the box, what multiplies to 36 but adds to 12? 6 and 6. You go up and over, this is what you get. But recognizing the pattern is key, okay? And the pattern we talked about before, and I'm going to use the first example on your sheet here. If both of the ends, we talked about there's 3 requirements for a perfect square trinomial. The first thing is that the ends must be perfect squares. And they are. What times itself twice gives you 9x squared? 3x. What times itself twice gives you 16? 4. So the ends are perfect squares. That's your first requirement. Second requirement is that the last sign must be a plus. Okay? And your third requirement is that if you multiply these two numbers together and double it, you get what's in the middle. Say it again.
So that's like 4.
So if it's a perfect square trinomial, which this is because it meets the 3 requirements, then to factor it, you take this, the first sign, and this squared.
Can you do like, you give us another one?
Yes.
That will come awesome.
Is it a perfect square trinomial?
No. Yes. No, one's not a
can use
perfect
7.
square.
What?
Actually, one is a perfect square.
One is a perfect square. Are the ends, so first step, are the ends perfect squares?
No. Wait, yeah.
Yeah, what times itself twice gives you 49x squared? What times itself twice gives you 1? Is the last sign plus?
Yes, it is.
Yes, it is. And then the last thing is, does it square dance?
Yeah, all right, can we do one more?
Square.
Wait, hold on now.
Wait, we haven't factored it yet. All you've done is told me.
Because if you double it, don't.
It's 14. That doesn't have to do with the sign here. The first sign is going to come into play because it goes here and then squared.
So now it's gonna be x plus 7 to the second.
7x minus 1 to the second. Square root of the first sign, square root of the last square.
Guys, practice makes perfect.
Hold on, wait.
But y'all know we've already learned this, right?
Let me write them all.
This don't make sense. I ain't no way to do it.
Yeah, you did, you just didn't pay attention.
I already learned this, I just remember using the square.
I remember y'all saying no, I'm just going to put it in the box.
I just,
For example,
Wait, can we-
You're not gonna do the box for the last one?
no, because I want you to learn this pattern.
11.
Why?
Is it 11?
Yeah.
Yeah. It's 11 and 6. What's the middle?
So go ahead and put that in the box, Gil.
Yes.
Are yours?
The first thing you should notice whenever you get big numbers like this is, obviously our first step in factoring is to check for a GCF, but whenever I look at something like this, the first thing that I notice are that the ends are perfect squares. So that automatically clues me in, could it possibly be a perfect square trinomial?
Yes, and it doubles to be 66, doubles to be 132.
Yes.
So the 11x minus 6 squared.
Yes.
So when they're perfect squares, ignore the middle besides the sum.
No, you have to check, because if this had been 121x squared minus 66x plus 36, that is not a perfect square trinomial. Because it doesn't square dance. If you take the ends, 11x and 6, multiply them together, and then double, it doesn't get you what sits in the middle, okay? So it's got to meet those requirements. It has to. So several of you said this one did, because 11 times 6 is 66, and 66 doubled is 132. So how does this one factor?
11x minus 6 squared.
All right, y'all are gonna really think this is a loaded lesson because that's not part of the lesson today. Well, it was just a review of what you've already done. So you have to use those. You have to use those because remember, we're constantly pulling on what we've already learned. All right, I've got 3 more patterns to show you. Those were 2 that we've already learned, and today we'll add 3 more to it.
Some of it cube.
You are correct. These are on your sheet. We're not going to factor and solve today. We're only going to factor, okay? So far, the only thing we've factored have been quadratics, things that have a power of 2, right? We can put them in the box. We can look for a special pattern. But now we're going to kind of up our knowledge to polynomials, which means even bigger. We've been working with polynomials with addition, subtraction, multiplication. So now we're going to talk about factoring them. I like to do 3 and 4 together, the sum or difference of two cubes. Now remember, if they're perfect squares, it's only difference, right? Right?
Right.
But if it's cubes, it can be sum or difference. So before we get into this one, though, tell me what it means to be a cube.
4.
Not in a geometric sense.
And you have
To the third power. We're talking about times itself 3 times. Give me some examples of some cubes.
4.
3 to the third, 27, 3x.
Give me like 27. What else is a perfect cube?
64.
64. 8. 2 times 2 times 2. Give me another one.
125.
125. Okay. At least these you really need to be familiar with. Okay. Yeah. 216. That's 6. Yeah.
Looking it up on the computer?
No, yeah.
All right.
Calculator.
Listen.
No offense, Maxwell, no offense.
You made that clear.
Listen. All right, so you need to be able to recognize these being cubes, okay? 343 is, yes, 73.
It's like 512 is 1, 2.
I don't know, that's that. All right. Sum or difference of two cubes. These have the same pattern. The signs are just a little different on them. So if I have two things, I'm going to say x to the third plus 64 or x to the third minus 64. Do you all agree with me that this first one is a sum of two cubes? Plus tells me it's sum, and the two cubes because what times itself 3 times can give you x to the third? What times what is x cubed? X. What times what is 64? 4. So they're definitely perfect cubes, and it's definitely a sum.
So then you just put 8 plus 4 cubed?
No, it's not quite that easy. Here's what you do. You put a little parenthesis and a big parenthesis. And y'all just stay with me. This is just a pattern you have to memorize. Set up your signs first. Same.
Also never do it.
Change.
Well, why are you doing it like this? Why are we not doing one problem at a time?
And plus. I'm doing them both at the same time because they're the same pattern.
Yeah, this is ridiculous.
All right, set your signs up first. Same, change, plus. Same, change, plus. Yes.
Everything.
Why didn't we do it on?
So the same, change, same.
No, because
It's same, change, plus.
same, change, plus. The last sign always has to be a plus. Okay? Now, you see these two numbers we wrote under here? Yes, you see them? No, you don't? Yes. Okay. That's what goes in your small set of parentheses.
And guess what?
Square the first and put it in the first spot.
Watch them out.
What the heck? Because you don't understand.
Square 4.
I get it.
Square 4 and it goes in the last spot.
Why does it go in the middle?
First one, first spot. Last one, last spot. You just got to remember to square them. And then the middle, put them together. So 4x.
What the, what? I haven't said what.
Why did it become so, like, easy?
You think this is easy?
Yeah.
It's just a pattern is all it is. Just like the difference of two squares.
I mean, I see what you did.
but it's like, it's not.
Is the minus?
The next one's exactly the same.
Oh, okay.
So it doesn't matter that it's a.
No. Now remember, all right, look. We're going to do several more and show you. The only difference here are the signs. Be very careful because when we're talking about cubes, it can be a plus or a minus. But when we're talking about squares, it can only be a minus.
So that's the
Right?
sum.
And the reason why you got 16, because 16 times 4 is 64, right?
I got 16 because 4 to the second power is 16. Or you could think about it like that. Yes, Lexi, you can think about it like that.
Question.
Yes. Let's do another one.
So that's the sum.
Hold on, so
Yeah.
everything over here supposed to equal, is that right?
Yes.
So that equals that,
Mm-hmm.
you should?
Mm-hmm.
Oh, I get
how.
Take a look at this one. Now, we're going to mix them all up here in just a minute. But my process for factoring has now changed a little bit because before I would check for a GCF and then put it in the box. Now I have to check for a GCF, check for a special pattern, and then if none of those work, put it in the box, if I can. Cubes like this can't be put in the box, though. So do you recognize it being a special pattern?
Yes, it's 2 and then it's gonna be, I don't know the next one.
So factor it. Try this one on your own. Little parenthesis, big parenthesis.
No parentheses? Okay.
Same, change, plus,
Okay, so, I have a question.
okay?
So like, I'm at the middle piece.
Mm-hmm.
I got it.
Thank you. All right, Tyler's gonna finish working it out, so y'all pay attention.
Okay, so
He's
it's
over here in my bubble.
I'm in the bubble. Okay, so it's gonna be 2x nothing, and then it's gonna be plus. It's gonna be plus 5. Then we're gonna plug it in 2x 5. We're gonna go over, and we're gonna square it.
Nah,
It's 4x squared.
it's
bro.
4x squared. You got to square both pieces when you square it.
God dang it! How do I erase it? I messed up. This is embarrassing. Okay, so I square it before I write it.
There you go.
So it's gonna be 4x.
Too bad you messed up that no homework thing.
Squared.
Ah, dang it. Alright, and now I'll square it and put it over here. This one over this over here.
Wait a minute, hold on.
You didn't square the
That would be
X.
4x squared.
Yeah, it's 4 squared.
Maxwell, you just want to know.
Why?
Go ahead.
25.
Yeah. I got it.
25. And then you're gonna put 2x plus.
No.
That's why I just asked and you said yeah.
I thought you meant here. No, multiply them. Don't add them. What's 2x times 5?
2x times 5 is 10.
10x.
Yeah, y'all thought I had this. But I guess I don't. 10.
Good. Wait, I have a question.
Yeah.
How did he get the 2x with 5?
What times itself 3 times gives you 8x to the third?
I asked you if that was right, Miss B. I was like, is it 2x in between the minus and the plus? Is it 2x or is it 7x?
You get our middle number, we just work out
Multiply
first
them
one.
together. Yes.
Okay, so we're gonna.
How'd you get 5?
What times itself 3 times
Let me
gives you
just smack-
125?
I'm gonna smack you under.
Oh,
He's
so
being quiet.
This, turn it into 4 and then square it.
Yeah, that's what I'm.
How is, say it again now, how is this?
Okay,
Turn
that's all.
into that.
Because if you do 2x times 2x,
Okay.
you get 4x squared.
I get it.
How do you
So
get
you
10x?
multiply it by itself.
So you multiply everything in here by 2.
You square it.
Okay, you square everything.
You move the 2x.
2x squared is 2x times 2x, which is 4x squared. 5 squared,
How is it still get, why do we still have a square? If we just square it?
the x is squared also.
So
Both
2 is
pieces.
squared, so these are separate numbers.
Yes, and they're both squared.
Okay.
But this middle number is coming because you multiply these two things together. Let's do another and see if you can recognize
Can we
it.
put it up for a second?
Can you what? I'm going to give you 3 examples, and I want you to factor each one, okay? Don't give them away when I put them up here.
Factor each one. Why is that the second, not the first?
All right.
Hold on. I kind of don't know what's going on. I just lied.
This is the only thing I put up since you left. All right, as you look at this, let's talk about some thought processes that should be going on as you look at it, okay? The first thing I ask myself before I factor, because all your directions are going to say are factor, okay, is I want to look at it and go, okay, is there something I can take out of both pieces first?
Yeah.
No, there's nothing you can take out of both
Wait,
of
well, are
those.
we talking about the first one?
Grab, thank you, Gil. So then I look at it, is it a special pattern? Is there a pattern to those numbers? What do I mean by special pattern? There's only 2 pieces there, 2 terms.
Okay.
They're both what?
Squares.
They're both squares. Do we all agree that they're both perfect squares? So if I have 2 perfect squares separated by a minus sign, then I have difference of 2 squares. So if you look at your sheet, that's number 1. When I have a difference of 2 squares, not cubes, you all tried to do this as cubes, I take the square root of the first minus the square root of the second.
And then x plus 2.
Yes. So that's that old pattern we already learned that will still keep popping up as we do special patterns, okay? Now the second one, again, I'm going through that same process. Yeah.
Why can't you do x? You know how you do the plus and minus on top of each other?
Mm-hmm.
You can do that in parentheses squared?
No, because that wouldn't indicate the multiplication, so you can't do that here.
So it's just a plus and a minus. Every
Yep.
time you do a plus and minus, and you just do.
When it's squares.
So you take whatever multiplies into the number. So say if it's like 99, you take 11 and 9.
Say that one more time.
Okay, so now you took 2.
99's not a perfect square.
Okay, so it has to be a perfect square.
These 2 have to be perfect squares for this to work.
Well, what if it doesn't have perfect square?
Then it's not, that's not the pattern. You
Then
can't
I
do
just
that.
have not doing it.
Yeah, it's not factorable if there's just 2 pieces like that. Unless you come over here and both pieces are perfect cubes. And now I've got the sum of 2 cubes. So this is where I do my little parenthesis
And then the big one.
and then the big one.
See, I did this one for the first one.
A lot of you did. As I was looking at your work, a lot of you did. Same change plus. What times itself 3 times gives you x to the 3rd? X. What times itself 3 times gives you 27? 3. Now you take the first and you square it, x to the 2nd. Now you take the last and you square it, and you multiply them together.
Question.
Yes.
So, if we're doing the cube, and say it's like 2x times negative 4, does the sign matter?
No, because you've already established signs in the beginning when you did same change plus. All right, so the very last one I'm looking at, I can't take anything out of all of them, so I want to check, is it a special pattern? Perfect squares and perfect cubes key us into special patterns, okay? Do you agree that these 2 numbers are perfect squares?
Yes.
What's the only pattern you know where both ends are perfect squares? We hadn't done that one yet. The square dancing one, right? Does it square dance?
Yes.
Yes. What's the square root of 4x squared? What's the square root of 49? If you multiply those together and double them, you get,
28x.
so yes, so how does it factor?
2x minus 7 to the second.
Okay?
that all we're on?
One more pattern.
Well, this next one.
Wait, so which pattern is that?
This is a difference of two squares. This is a sum of two cubes. Shh, guys. And this is a perfect square trinomial.
You need to be quiet so you can understand.
Preach it, why?
Factor by grouping. Grouping. This is kind of like a double GCF problem, okay? This is the last pattern.
I can only imagine.
Whenever 5 minutes. we all-
Cállate tú, cabeza. That made no sense. Cállate tu boca.
Oh my God, yeah.
I'm going to change this slightly off of what's on your paper. All right, so when I factor by grouping, here's what I want to do. I notice that there's 4 pieces here. Okay, anytime you see 4 pieces, I want you to try to slash it. Okay, and when I say slash it, what I want you to do is look at the first 2 pieces.
So break it down into 2 problems.
2 separate problems to start with. Is there anything you can take out of just the first 2 pieces?
Yeah.
What?
The X.
The X. What's left if you take an X from both of them?
2.
X plus 2.
Oh,
Okay.
you still have to put it outside.
I'm going to bring this plus sign down. Yeah, you still got to put it outside. Now look at the second
You can divide it by 9.
2. You can divide both of them by 9. So if I put a 9 outside, what's left?
1x, x plus 2. That's the same problem.
Okay. What? Yeah, and you noticed exactly what I wanted you to notice whenever you did this.
So it's x plus 2, and then you have x plus 9x minus 2?
All right.
9x minus x plus squared. X plus squared.
You don't want to square it. Yeah.
Say if 18 was 21, then you'd use 3 on the outside.
18
Yes.
was 21 and put 3 on the outside.
All right. Shh, shh, shh.
Okay, so I get where you get all the numbers from, but it's the fact about putting it in, that's where I was like, well.
What you mean put it
Like,
in?
I know how you got it, I know where you got the 18 from, cause 9 times 2. And I know where you got that x2 and that times 2 from, cause you got 2 x's and 2, that's what I'm going off of,
That's right.
but I don't. I'm confused how you put it in the parentheses.
So what you take out, you put on the outside, and what you have left goes on the inside. So here, if I can divide them both, it's kind of like whenever you go, if you're in the box and you've got a 9x and an 18, what would you say the GCF is there?
No.
9.
So what you do?
That's what goes on the outside. So now if you divide each of these by 9, what's left? Well, 9x divided by 9 is 9x divided by 9 is 1x. What's 18 divided by 9? 2. You take the GCF and you divide both of them by it. And that's how you get what's in parentheses. Now, just like we pulled a GCF out that was just a number or a variable, now we're going to now look at it as a whole problem. My whole problem is x times this plus 9 times this. So now my GCF is that x plus 2. So I'm going to take that out and write it on the outside just like I would any other GCF. I don't need to write it twice because you don't write it twice when you take it out. And what's left? X plus 9. Now it's factored by grouping.
That's all you got to do.
All right, look, these pieces must be the same to do this.
Wait, what piece?
No, not that one. That's all you can do.
Are we gonna work them out further?
We'll do more with them, but right now, I just want you to recognize that pattern and be able to. Let me do another. All right, take a look at this one. It keys me in that it's factoring because there's that it's grouping because there's 4 pieces. So I'm going to automatically try to slash, okay? So look at the first 2. Is there something you can take out of the first two? X what? Squared. What's left?
Hold on, man. I'm moving this way.
Now, before you start taking out of the next one, remember I told you this sign has to stay, right?
Yeah, so I have to minus.
So if the middle sign is ever minus, it changes the last sign. Because remember we talked about when you take it out, you're dividing? If you divide this by a negative number, you're going to get a negative. So if the middle sign is minus, it changes the last sign.
So then,
So what did you say you could take out of those?
16.
16. What's left?
X is 3.
Plus or a minus?
Minus 3.
Minus 3. Because if this middle sign is minus, it changes that last sign.
You can just,
Okay, keep going. You could just what? What do you notice is the same? That's going to be my new GCF. What do I do with GCFs? I write them one time on the outside, and I take it away from both. I take it away from this one, and then I take it away from this one.
You're speaking another language.
Look what's left. If you take an x minus 3 off of both of them,
it's X squared minus 16.
what's left? X squared minus 16.
So, now I'm confused on the X minus 3. Is that just like both of them together?
Yes, okay, look, if I had,
But when you have to put a square there,
watch, if you had this equation, and I asked you to take out the GCF, what's the GCF there? X squared times y minus 16 times y. Does it have something that you can take out of both of them? The y. Do you agree? If you take the y out, do you write it twice or do you write it once?
Once.
And what's left? So if you only write it once here, why do you want to write it more than once here? It's just a bigger piece. If this were y, you just write it the one time. It's just that now my piece that I'm taking out is bigger. It's a whole chunk I'm taking out of both of them.
so we keep one of the.
How do we do that?
I'm not quite done with this one. I hope someone has seen it. I'm surprised nobody has
You
said.
said you're not done with
You
it.
can simplify your X squared.
Yeah.
When you are factoring, you have to do what we call factoring completely, which means you check the pieces to see if you can factor more.
What was that?
Okay? Factor completely means you can't factor it anymore, none of the other pieces. And several of you said, oh, look at this one. How does that factor? Give it to me, the whole thing.
X,
All right.
X minus 4.
X minus 2. No. Do X minus 8.
You can't do 8.
Wait, I thought you were splitting them up to like X minus 8. X
Perfect,
plus
it's a
2.
difference of 2 squares.
Not doing
That's a
that.
difference of 2 squares?
Difference means subtract. See how you're going to have to pull back on that information we already learned?
16 doesn't have to be squared to be a perfect.
You told me. That's all I'm saying.
Let's do one more.
Oh,
Okay.
is that right?
27x cubed, huh?
Have you been those?
Oh, yeah, then I can't remember
Just
the
be,
next
you
day.
did not know I just said in Spanish, but I said it in English.
What'd you say? Ay caramba?
Ay caramba?
That's not a bad
That
word.
black job is on today.
You caught that.
Miss McGee, Kebasa.
No, dude, it's,
Coco.
no, it's Miss McGee, that's cabeza de coco.
This could be Miss McGee.
Jennifer, what's the cabeza de coco?
Why are you talking about Miss McGee?
For now?
She doesn't know what we're saying.
I'm gonna change this example because this is a terrible example.
Oh, we
Let's
already-
do.
I had already wrote that down, Mr. G.
I'm sorry, I do apologize. Let's do this one. 3x squared minus, actually 3x cubed minus x squared plus 9x minus 3. Slash it.
Watch it.
What can you take out of the first two? Squared.
So you have 3x at 3x minus 0. Well, it's just 3x parentheses. It's gone.
If, remember you're dividing,
Minus X.
if you divide x squared by x squared, what do you
And
have?
0.
1. Anything divided by itself is 1.
No, it's not.
Yes, it is.
You said take away, so that means you're subtracting.
No, but you're dividing by whenever you do greatest common factor.
3.
First sign, what can you take out of these two?
3.
What's left?
3x
Just 1.
minus 1.
Minus 1.
Can it group?
Yeah.
Sure. It can group if those two patterns are if those two factors are exactly the same, and they are. So on the outside, I take out this GCF. Only write it the one time. And what's left?
Plus. Why should it's supposed to be plus, Mr. G? Okay, I understand.